What is up, everyone? In this video, I'm going to talk a little bit about streaming, bi-directional streaming in Grpc. I have my GG Poker project open. For the people that don't know what GG Poker is, it's the decentralized poker engine that I'm building for quite a while right now, and which basically we rewrote a lot of stuff a couple times on the stream, going from our own peer-to-peer implementation to a Grpc version with proto buffers and all that stuff. And right now we have this RPC way of handling things, right? But I want to explore Grpc bi-directional streaming for a couple of reasons, which I'm going to show you. And then we're going to try to explore it a little bit and see how it behaves. But first of all, if you like the videos I'm providing to you, please consider subscribing to my channel if you're not already. Leave some questions in the comments, give me a thumbs up, and of course, jump into the Discord community. All right. So basically, GG Poker is a decentralized poker engine, completely decentralized and distributed with no central authority, yada, yada, yada. There are a lot of streams already on my channel, so check it out. But this video is going to be a little bit more focused. So basically, let me open up my proto thingy real quick. So we have this gossip server. And we have a handshake, we have a handle deck, we have handle take seat. Of course, we have in our own implementation, our own peer-to-peer protocol, we have a lot more, right? Basically, we can do a lot of stuff. We can bet and fold and check, and everything is working so good. Although we have a little bit of a complexity problem there. That's why we basically, that's why I decided to rewrite this, the gossip thingy in Grpc, right? And we are using this RPC stuff. That's fine. But I was thinking, basically, that you need to understand that each time, right, we are in a distributed environment, right? We have all these peers, all these players connected with each other. And each time you're going to send, there's a lot of message communication going on, right? And it's all it's all asynchronous, right? There is no way to determine when a message is going to be received and from who that message is going to be received first. That's basically the complexity we have when working with these distributed systems, right? So each time somebody is going to send a message to one of a peer, it's basically with RPC, it's going to handle that message on its own, right? So if somebody is basically sending 10 messages at the same time, we have one player and that player is going to receive 10 messages from all the players, right? Or maybe a couple from the same player, whatever. Then basically what's going to happen is our server or node is going to handles all these messages at the same time, right? Or trying to do that at the same time, kind of at the same time. And that's why we need to have in our game state and all that stuff, right? Let me open up game state here, right? We have a lot of atomic stuff going on, a lot of mutexes, this player list. Let me quickly see that. There's a mutexes and locks all over the place, and still, most likely we're going to have, sometimes I can see it, I can spot some race conditions here, and it's very, very, very hard to keep track of that, and to debug that, and even to test it, right? It's a hell. That's why distributed systems at scale, well, you cannot call it scale, but that's why distributed systems in general is just a pain in the ass, right? It's complex. It's complex. So a little bit of coffee here, right? All right. So basically, why can Grpc streaming help us, right? So you need to understand right now we have this RPC method, so everybody can just send a message, and we're going to handle these messages as they come. But if we open up a stream, between between player A and player B, and then with all the other players, of course, if we can open up a stream, then we have a single point of handling these messages, right? So we open up the stream, these messages come in, right? So we're gonna have a general message, and then we're gonna basically have a one-off type in our proto buffer, right, where we basically going to assert or we're going to check what kind of message is being sent, and based on that message we're going to handle that. And by doing that we can basically handle each message. Although we are going to receive 100 messages at the same time, we are going to be 100% sure that we only gonna handle one message at a time. And the reason why I come up with this is because I'm working right now for Trading Light, and they're using an actor model, right? And for the people that don't know what an actor model is, look it up. It's a complete different paradigm, the actor model. It's basically how Erlang handles things, right? And it's the same principle, right? So there you don't have the concept of course you have the concept of state, but you don't have the concept of keeping to synchronize your state, because you're going to handle all these messages one by one with some kind of a queue system, right? So even though in a concurrent distributed environment, you're going to receive 100 messages, you're going to be 100% sure that these messages are going to get handled one by one. Hence, your state can be freed from all these locks most of the time. Of course, if you're doing things in a Go routine yourself inside of your program, inside of your node, of course, then you need to be careful, because then you can have these things. But still, we don't do that, right? The only concurrency we have is the handling of these messages coming from all these different players, right? This can be boring, but hey, it is what it is. I needed to do this. I needed to explain this a little bit. Right, so basically what I'm going to do is I'm going to try to explore this real quick so you guys can also see how this streaming could work, right? I'm not quite sure if it's how I'm going to do it. I'm not going to implement it completely finished right now. I'm just going to explore and show you guys how that's gonna work. Could work, actually. So the first thing we're going to do is basically here, I'm going to do an RPC, and I'm going to call this, I don't know, maybe a gossip stream or something. And that's going to basically, man, this font is huge. So first of all, we're going to make a message, a general message, which is basically going to call message. Isn't that easy? Right, we're going to, first of all, basically what's going to happen here we're going to have some kind of a one-off or something. I don't know, I need to check. With a list, an enum actually, a list of things that can happen, right? Check, raise, fold, and all that, take a seat and all that shenanigans, right? It's basically a wrapper, an envelope, right? It's what they call it sometimes. So we're going to have RPC gossip stream. That's going to be a stream of message, just like that. And we're going to return also. Is that a stream? Probably a stream message, not quite sure. And then we're going to basically make proto here. Boom. And that's going to be perfectly fine. So then in Node, we need to do our implementation, right? So we have this handshake, which is basically also an implementation, but an implementation of an RPC instead of a stream. It is what it is. Right. So we're going to say here, func n, a pointer to our node, and we're going to say, how is it called? Gossip stream, probably. Gossip stream. It don't take a context. I think it takes in a stream, what they call it, and it's going to be also no pointer. It's going to be a proto gossip stream server, I guess. Gossip a stream server. That's what we're going to do. It's going to return an error. We're going to say return null here. That's that. Let me quickly do make run to see if the implementation is right. Yes, it is. It is this. We are Gucci. What we could do here is fmt println, and we're going to say received message, something like that, and it's going to be, I don't know, received message with no message. Not quite sure how I'm going to. It doesn't matter. We're going to explore it later on. So we have this gossip stream. Then we're going to open up our main thingy, and we do a lot of stuff here. With what we're going to do is we're going to actually return here, leave that open. I'm going to yoink this. So I'm going to quickly make a node here at level, at port 3000. And this, if you're wondering, this 3001 is basically the API port. So we spin up a server, a Grpc server, and then we spin up a JSON API server to do some stuff, right? Like I said, if you want to know more how this thing is being built, there are a shit ton of live streams. Yeah, I know live streams not maybe the best to rewatch all the time. I know, but hey, it is what it is, right? Take some popcorn, some coffee, and have a good day. Make server and start. So what we're going to do is make a client real quick, and I'm going to yoink some code from Node real. Like I said, we're going to do this quick and dirty, right? That's who I am. That's how they call me. Make Grpc client. So I'm going to copy this function here because it's basically not exported. What is this? All right. Make Grpc client connection. That's fine. Then we're going to say that the client error is going to be make Grpc client com. And we're going to connect to our server here, node 1. Right, don't mind these things behind return. I'm just doing a return, so I don't need to comment it out. Right, so we're going to do an if error. What's going on here is not nil. And we're going to do a log fatal, maybe. Log fatal, this error, right? Then we have a client, right? And then it's a bit weird, I guess. But what we need to do then is basically say that the stream, right? We're going to make a stream. And it's going to be interesting if we're going to really handle this stream in how we're going to keep track of these connections from all these players as a stream. So I need to think about that later on. And that's probably going to be in a stream, or maybe if you guys like that I stop streaming and I make these more focused videos that are a little bit shorter than 2-hour stream, which is probably hard for you to navigate what you want. I understand, but hey, please help me. Please help me make a decision about this. So we have a stream here, and then we're going to say, it's probably also an error, and that's going to be a client, and then we need to call this gossip stream, right? And this is going to be a context, I guess, not quite sure. Yeah, it is. And of course, like everybody, we're going to do a context to do here real quick, of a background maybe, I don't know. Let's do a background. Then we have an error. We're going to handle this like always. Then we have a stream, right? So what we could do then is basically we can send and receive from the stream, right? We can make it a one-directional stream and a bi-directional stream, whatever you want to call it. So we're going to say stream sent. And we also have send message. I'm not quite sure what the difference is. It's going to be an interface, and send is going to be a proto message. That's actually interesting. Doesn't really matter. So we're going to say send. Actually, that's interesting. Can we actually send whatever we want? It's by generated code. Okay, I see. We need to stay away from that. Classic Grpc. There are a lot of stuff going in that nobody knows what's going on, right? Grpc is like a black box full of magic and sorcery and wizardry. You have something that is called Grpc, which is basically a stripped-down version of Grpc. Because in Grpc, basically everything is outdated, is deprecated, and it's crazy. Yeah, that's why I'm only using the simple functions and just stay away from all the rest. And you should do too. Maybe I should make a video about Grpc. What is Grpc? It's basically, I don't know, it's a fast version and a stripped-down version of Grpc. All right, so we're going to do stream sent, and then we're going to say a proto message here. That's our message, which basically is nothing in this case. What's going on here? This font, guys. I'm so sorry. Sent. Why is this not working? What do we need? Nothing, right? Proto message. We cannot do that. We need to do this, of course. And the question rather is, what is it returning? An error. Okay, cool. So we're going to say if r. Still rusty, what's going on? We're going to basically do a log fatal here. Fatal r. Just like that. Right, so we're going to open up the stream. And then we're going to send basically an empty message, which basically is going to trigger on the other side here. Is going to trigger... wait, it's going to be gossip. Let me search for what I need here, right? It's going to trigger the received message, right? If all goes well. And basically what I'm going to do here is do a select. So we actually block, because if we don't do that, we're going to return, and most of the time we're not going to see the log here from the server because we're already returning, right? Let me see, make run, if this is going to work. Boom. So we received the message, it's working. That's fine. So, of course, what I think we should do is each time... like I said, I need to think about that. But how it's gonna work in our poker engine, right? How we gonna keep connect? Because how we gonna keep track of these connections? Because we need to keep them open, these streams, right? We need to keep them open. And so we're gonna have, for example, in our message proto buffer message envelope, we're going to have we're gonna have a message in there, which is basically a connect message, which is just a one-off message where people notify each other that they are trying to connect, and then we need to basically put them inside of a map of connections and all that stuff, so we can then, if our poker engine, for example, if we want a fault or something, we need to broadcast that fault to all these connections, right? Some kind of a chat, basically a chat system. Well, not a chat system, but like the broadcast itself is basically the same. You want to broadcast the whole shebang, right? Everybody in the party. So basically, you could do something like this, right? For, we can have a for loop, otherwise it's not going to work. Yes, we're going to have a for loop, and we're going to say that the message, probably error, is going to be stream receive, right? Of course, we're going to say if there is an error and that's not nil, we're going to return the error here in this case. Can you guys? Yes, you can see that. We're going to return the error. Then we have a message, so we could say an fmt println. And of course, we know this message for now is just going to be a simple empty proto.message, right? Received MSG, something like that, actually. Let's delete that. We're going to loop here. That's fine. This will never be triggered. This is what it is. The same thing here. So in our client, so what I'm going to try to do is basically I'm going to send off a message from the client to the server. The server is going to respond. Actually, we don't respond, right? So we're going to receive a message here. And then we're going to say stream send. We're going to send a message, and it's going to be... Let's send it back, right? Let's send it back. Why not? And check the error, of course, right? So I'm so sorry that I'm a little bit rusty in typing, but this font is like, it's insane. But yeah, and I take that for the team. All right, so we're gonna do the same thing. We're gonna make this stream here, and then we're gonna do a for loop, right? And basically, I'm gonna delete this, and I'm gonna actually, to be honest, I'm gonna copy the whole shebang here. Boom, paste it in. Of course, we need to do a log fatal here because we are in the main. Like this. Let's copy this up, paste that in, delete this, call it a day. So received message. We're gonna say here received message from the client. Let's call it peer, client peer. And then receive the message from the server peer, something like that, right? Yeah, and another thing is basically the problem is that in stream receive is basically gonna block until we receive. So we're not gonna send here until we are receiving. So the question is, do we need to spin that up in a Go routine? Maybe, I don't know. But for now, to make it simple, I'm gonna copy this, right? And I'm gonna paste it in here. We're gonna send a message, which is gonna be, in this case, we need to do a proto message right here. Then we're gonna receive the message from the server, and then I'm gonna sleep here. Otherwise, we're gonna ping pong like crazy. So we're gonna say time sleep, and we're gonna say time second or something, and that's fine. Of course, this select loop is not needed anymore because we are basically in a for loop. And yeah, I think maybe that's gonna work. Not quite sure. So we're gonna say make run. Yeah, so we receive the message from the client, and then we say received message from the server because we are ping ponging. Of course, that other logging is basically the game state that basically logs every, I think, 5 seconds the state, but don't worry about it. So that's basically streaming in gRPC. So like I said, tutorial code, right? That's something you guys need to understand, that tutorial code is easy, right? You see it's working and wow. But actually, if you're going to implement that at scale, if you're going to implement these things in a real case scenario, a lot of other troubles rise up, right? That's the thing. That's why I don't like to do these simple tutorial most of the time, because it's all going to work perfectly fine until you guys are going to use that and implement that in some kind of a system. and you're gonna choke because a lot of things are going on. That's what it is. But hey, I just want to make this video to show you guys this. And I'm still working and I'm still thinking about our beloved poker engine, that I'm not gonna dump that project into the dumpster. So basically, what we're gonna do then, of course, we need to do a lot of stuff in this node so we can keep track of these connections and disconnect and connect and all that stuff. But that's for later on. But the main thing to take away is that from now on, we're gonna have this one stream open. We're gonna delete, basically, if we open up our proto, we're basically gonna delete these stuff, right? All these things are gonna get commented or deleted, and we're gonna handle everything from this centralized gossip stream thingy, and make sure we basically handle all these messages one by one. So we are, so our state is released. Our state is basically released, of course, unless we are doing some shenanigans ourselves inside of our node, and we're spinning up our go routine, and we are adjusting the state on ourselves. That can cause, of course, data condition. That can pollute the state, right? That can cause inconsistencies. But if we're using messages coming from everybody else and we're handling them in a centralized, synchronous way, there is no way we can have problems with race conditions and problems with our game state and everything. And because you need to understand that a poker engine or a distributed system itself is going to be, there's a lot of state going on, a lot of state. And with all these locks and all that, so at a certain point of time, it's going to be so slow and it's going to be so hard to keep track when to lock, when to unlock, what's safe to adjust without. It's just a mess. And we don't want to have that complexity. So that's why we're going to use this stream. Right. So if you like these videos I'm providing to you, if you have some questions, hey, please feel free to jump into the Discord or jump into one of these streams where I'm making this live. And we can discuss a little bit more further if this is a good approach, yes or no. Consider subscribing to my channel if you're not already. Give me a thumbs up, leave some questions in the comment, jump into the Discord community. And I'm looking forward to see you in one of my live streams. Cheers.